Hi guys, and welcome back to a little algebra work. We're going to be tackling the second half of chapter 8 as we finish out this course. So just 4 lessons left for us this year, okay? And those are going to be lessons 8.6, 8.7, 8.8, and 8.9. And we're going to skip 8.5 for various reasons. I'll explain later. Okay, we're going to start in on 8.6 today, okay? The rest of the chapter is going to be all about solving quadratic equations, so anything with x squared in it, okay? We're going to learn various ways to solve quadratic equations. Okay, in 8.6, we're going to learn how to do it by factoring. In the next lesson, we're going to learn how to do it by using what we call the principle of square roots. In the following lesson, we're going to learn how to do it by what we call completing the square. And in the final lesson, kind of the end of the course, we're going to learn how to do it using what we call the quadratic formula. And if we get to it, well, I'll actually show you how we derive that very special quadratic formula, okay? This lesson is all about solving quadratic equations by factoring. Now, I'm excited about this lesson because, as you know, I recall in class, I would talk a lot about the importance of factoring. And I love factoring. I love to factor. It's one of my favorite things to do in algebra. I think it's kind of fun. Factoring is like a little puzzle to solve. But we always kind of had you think in the back of your mind about why do we factor in the first place? What's the big deal? So we change a polynomial. We change its form into a factored form. So what? Well, this lesson is finally going to tackle the answer to that question. So what? Why is it such a valuable tool? Why is factoring so important? Okay. So we're going to get into that. But first, we need to talk about a principle or a property here. One of the most important and fundamental ideas in all of math. And I'm not kidding. It's no exaggeration to say that this idea here that we're about to share with you here, called the zero product property, is one of the most important and sort of useful ideas in all of mathematics. It'll take you all the way through calculus and beyond, okay? It's such a simple idea, and it's called the zero product property, okay? And that's what our book calls it. That's what it's generally called. It can also be called, some textbooks refer to it as the property of zero as a product, okay? But this title is as fine as any, the zero product property. So we need to look at this and understand it first. I haven't written it yet. I'm about to. But what does the zero product property say? Okay, because it's this property combined with factoring that's going to basically provide us a key to open up the door, to unlock the doors for solving quadratic equations we couldn't solve in the ways we've learned up to this point. Okay, so this will be a brand new key for us. Okay, the zero product property, very simple, simply says this: for all real numbers a and b, if a times b, so two real numbers, a and b, if a times b equals 0. Now just think for a second what has to be true as we finish the conclusion for this property. Then what has to be true? If two things multiplied together give you a 0, then what has to be true about either one or both of these a and b? What has to be true about either a or b? Either a is 0 or, I shouldn't capitalize that, excuse me. Okay, or b is 0. That's it. That's the zero product property, okay? Let's let that sink in. That's so important, okay? That idea is going to carry us through this entire lesson and beyond, okay? Take a look at that one more time. Let it sink in. The zero product property says, if a times b equals 0, then what must be true? Either a is 0 or b is 0. One of those expressions, one of those terms, numbers, has to be, one of those factors has to be 0. Hope that makes sense, right? Very simple, elegant idea, but incredibly useful. And I'm not kidding when I say you're going to use that in calculus and beyond. You're going to use that all the time. And this is your first introduction to that idea, okay? So let's see how it works, okay? But I wanted to really freeze on that screen there for a while. I want that to sink in. I want you to, if you're taking notes on this at home or doing your homework, you should write that down and memorize that. It's really easy to memorize. Memorize that property, the zero product property. If a times b is 0, then a is 0, b is 0. Okay, we get it. So let's look at how that plays out with a real kind of situation. How does that help us, okay? So I'm going to look at, in the book here, in our HMH book, I'm just going to pull example 2 here, all right? Which says, this is example 2 in our text, and it simply says x squared plus 7x plus 10 equals 0. Okay, so what do we have? We have a polynomial here, okay? But for the first time, we have this polynomial that is part of an equation. When we were doing the prior chapter, chapter 7 on factoring, we were never actually solving for x at all. We were simply factoring. We were just factoring polynomials, just changing the polynomial expression from x squared plus 7x plus 10 into its factored form. Now we actually have an equation, okay? So now we're asked to solve, okay? We're asked to solve for x, all right? So this is a good example to start off with because I want you to notice that in this example, the equation is already set up so that the polynomial here is on the left side and all of that is set equal to 0, okay? And that's gonna be what we want. That's gonna be what we want to kind of to start with so that we're ready to factor, okay? You will see some problems in a second. In the next video we'll do some more demonstrations of this kind of thing where it's not always set up to 0. And your first task is going to be to set everything equal to 0. But in this example, that's already done for you, okay? Now, this is so simple. What are we gonna do with this expression? Well, we're going to factor it, okay? And I wanna pause for a second and just talk about, why we do that. Because normally, up to this point, when we've been solving linear equations, what do we do to isolate x? Well, we use inverse operations. We undo to x things that are being done to, with, and around it, right? We undo things in a certain order to undoing things, okay? But I want you to notice that if we kind of went that traditional route, all right, let's say we tried like subtracting 10 from both sides, we're gonna get stuck. We would have x squared plus 7x equals negative 10. Then what would you do? Some guys might say, maybe you subtract 7x and then maybe you take the square root of both sides. But if you follow that route out, what you'll see is you haven't really isolated x that way. My point in doing this is what we're not gonna do, is that this won't work. This won't get you anywhere, okay? So instead, we're going to see why factoring is so important. We're gonna factor this, okay? So this is an easy one. This is as easy as factoring gets, okay? Don't forget to keep writing equals 0, by the way, okay? So let's factor it, okay? This is as easy as factoring gets. X and x, right, is the only way to make x squared. What are your two numbers gonna be that make 10 as a product and 7 as a sum? They're gonna be 5 and 2, right? Both positive, of course, all right? So simple factoring, okay? The point of this isn't to struggle with the factoring. The factoring by now should be easy, almost automatic, okay? Especially for something that simple. Now, think about the zero product property we just learned. What did it say? It said, if A times B equals 0, then either A is 0 or B is 0. So in this scenario, what is your quote unquote A and what is your quote unquote B? Well, the A is this first binomial factor, the x plus 5, and the B is the second binomial factor, the x plus 2. So what must be true? If this times this equals 0, then what must be true? And this is how I want you to write this on paper, okay, or on your work, wherever you're doing it, is x plus 5 is 0, or, okay, and please do use that word, that is the correct word, okay, or x plus 2 equals 0, okay? And then now it's a simple matter of solving as you normally would. Okay, subtract 5 from both sides. What do we get? X equals negative 5, okay? Or x equals negative 2, okay? And there are your solutions. And notice I said solutions, plural. Yes, there are two solutions now, okay? And now we're getting at another important idea that it's at the heart of what you'll later learn is called the fundamental theorem of algebra, which basically says, and I'm gonna kind of give you a watered down version of it, the fundamental theorem of algebra basically says that whatever the degree is of your equation, so go back to the original equation, what's the degree? The degree is 2, right? X squared. The fundamental theorem of algebra basically states that if whatever your degree is, that is the number of solutions you can expect to have. There's some nuances to that we'll get into in Algebra 2, okay? But basically that's what it says. You have a degree 2, you can expect 2 solutions, okay? All right, now again, I kind of want to correct myself because there's more to that. You could have imaginary solutions, you could have solutions with multiplicity, yada, 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 all this stuff you'll learn in Algebra 2. But basically, that's what it says, okay? Expect 2 solutions, okay? We'll look at lots of examples later where we get one solution that's what's called a double root, okay? But I don't want to get into that yet, okay? 2 solutions, so we would box both of those, okay? And in fact, the way I'm going to have you write your answer to something like that on paper, I'm going to show you here in the last remaining space on my whiteboard. I really need a bigger whiteboard, I think. Is the way we're going to express these two answers. This is okay. You could box these up if you wanted, okay? All right. And the word or is important. But the really kind of the proper way to write those two answers is to use what we call solution set notations. Those are, I'm not a good drawer of this. Those are my set of braces, okay? And we're going to put our two solutions in that set separated by a comma. So -5 or -2. And that's kind of the more technical, kind of professional way to express that answer, okay? -5 and -2, all right? So that's an introduction to this lesson and to the idea of this lesson, okay? Again, the zero product property is what makes all this possible. The zero product property and factoring are at the heart of this lesson, okay? In the next video that I'm gonna do for you, we're just gonna do, 2 or 3 example problems where we have to use factoring to solve quadratic equations, okay? I hope that was helpful. I hope you're hearing me emphasize how important the zero product property is, okay? All right, everybody, hope that's helpful. Take care. I'll see you in the next video. Bye.